live from New York, it's Ask This Engineer.
Hey everybody, and as you saw our lovely little introductory video, we are here at the Adafruit factory in downtown Manhattan in Soho, and I'm Lady Ada. With me is Mr. Lady Ada, and this is where we do everything that we do. The magic happens here. This is our Disney World.
That's right.
You are the frozen head of Walt Disney.
All right.
I mean, why not?
It's just a rumor.
Maybe. Anyways.
Maybe we're all a dream inside the frozen head.
Getting a little weird here, but we have an exciting show for you tonight and a lot of cool videos, a lot of new stuff this week.
Yep.
This is getting back into this little fall groove as we make our way to Halloween, which is our favorite maker holiday, and then the holidays, which is a great time also for makers, lots of gifts and gift giving.
Yep.
So let's kick it off. Tell them what's on tonight's show.
All right, on tonight's show, the code is OpenDoc. We're celebrating Open Documentation Month in the world of open source hardware. Show and tell. People around the world showing and sharing their project. It was an epic show and tell. Lady Ada will talk about folks on show and tell and more. Mailbag, your letters to us. Time travel, look back in the world of hackers, makers, artists, engineers, and more. Some footage from the factory, some 3D printing, some new products. We'll answer your question. We'll have a trivia question, all that and more on, you guessed it, Ask an Engineer.
Yay!
Okay. So first, pay some bills here. We are 100% supported by you, the customer. So if you purchase something and want to save a buck or two, use OpenDoc on checkout. 10% off Adafruit products, except for gift certificates and software and AdaBox. But we're here because of all of y'all. So thank you for your support. We'll keep doing these shows as long as we can keep the lights on. Okay.
Literally, like it was dark, you wouldn't be able to see us. It would be super awkward.
Yeah, it would be a little scary. Programming note, this is Ask an Engineer. We do this every Wednesday at 8 p.m. and show and tell is every Wednesday at 7:30. We have our free UPS deal going on, $200 or more UPS ground. We have our same day shipping in Manhattan if you check out before 11 a.m. It is, 'tis the season. There are many advertising agencies and creative firms that are buying LEDs at the last second. So that's been working out. And just a little reminder, next week, if you all want to show up on the show and tell at 7:30 p.m., show up with your costumes and more. It's getting close to Halloween, or the week after. It is our show and tell every single week. Lady Ada, our favorite half an hour. Who's on the show and tell this week and what they show?
Okay, so last week we had a lot of pumpkin projects. There was like 3 pumpkin projects. This week we have 1 pumpkin project and a bunch of costume projects. So let's kick it right off. Starting off with the pumpkin. Phil B had a circuit playground pumpkin tutorial that was live this week. It's a no soldering. You take your circuit playground, plug in a battery pack, upload this code, and it simulates a flame flicker, like a randomized flame effect. A great way to make a safe pumpkin accessory and a good way to learn about randomization and LED lighting. So it's a good quickie project for this weekend if you want to do a circuit playground project. Noe and Pedro worked on a couple things. So first off, Noah has this awesome Fix It Felix cosplay project that they documented a video for. It's like the most adorable thing. There's like a hat with a badge and like the Dickies shirt with the badge on it, and they 3D printed a whole bunch of parts, including this hammer that it's like the hammer that Fix It Felix has in the movie, and it has a sound effects board in it. No programming required, and you just load some audio files and it plays sound effects from the movie. So you can actually, when he, pushes the hammer around or whatever, I guess like bashes bad guys or fixes buildings, it will make sound effects, and so he will have a really cool costume for the next couple weeks, and he finished early, so check out that video. And then Pedro's working on a GoPro UFO, so a little UFO mount that adds NeoPixels to your GoPro mount on your DJI or similar drone, and it will make your drone look like a flying UFO and scare some kids. Tony D had a video today, I think, or last week, Desk of Tony D, a guide for loading and using MicroPython for the Feather and M0. We are releasing our beta firmware for the Arduino Zero and the Feather M0, the SAMD21 processor. You can now run Python on the microcontroller, so you basically connect to the serial port and you can just start typing Python as if it was like any Python REPL. And we also have a little file system on there as well, so you can save files to it, so it's kind of neat. A lot of movement's going to be happening with that, but if you're interested in trying it out, We have a couple drivers written, a couple things working on it, and it's super fun, and it kind of blows your mind. You know, what I like about MicroPython is we still get people who come up to us at like events, and they're like, well, you should really teach people like assembly. You know, that's the way to learn microcontrollers. And so like,
You got to cut your teeth on something close to the metal.
and so I love how we're like it's now interpreted. Like there's no compiler even. So it's like mind blown. And then John Park also had a video this week, the test tube sci-fi rack. It's like this glowing UV LED, like quinine solution, glowy test tube, super creepy. A great decoration for your haunted house or a cocktail party on Halloween where you can have gin and tonic, because gin and tonic glows under UV black light. It's like one of the things you learn in college.
Yeah.
That's pretty much all you learn. That and Fourier transforms. And then we had non-Adafruit folks. We had Kit, who built a old school TV, like a little miniature television with like the dial and the knobs and everything. Like when I was a kid, and it built with a 5-inch Pi TFT add-on backpack that we sell. So went to Micro Center and picked that up. Thanks for buying from Micro Center. They're our partner. And then Stuff with Kirby also had a Fix-It Felix outfit, but that actually wasn't what he was showing off. He actually made a binary guessing game to teach binary, so you have to flip the switches to match the binary number. And what's really interesting is apparently you can simulate Arduino stuff on Circuits.io, which I'd never seen.
Yeah.
So it was like simulated. And I got to check that out because I didn't realize that it would actually run code. But
Virtual Arduino.
Virtual Arduino, and also a really beautiful CAD model of this wooden case that he's working on wiring up tomorrow or later on this week. So check that out. Very cool. And then Richard had his outfit, which is like a zombie boss costume he works on every year. And every year he works on it and improves it. And he had a couple workshops at the Makerspace where they used sound effects boards to add sound effects to people's costumes, and they loved it, so it's great.
Yeah.
Ron works at a university and is, I guess, on some IT staff. And they have a problem where people need to know their MAC address to get added to this IoT network, but people don't know how to figure out what their MAC address is, and it can be very challenging with some devices. So he made a feather huzzah that when you connect to it, it acts as an access point. When you connect to it, it prints out your MAC address, which is like so smart. It's like such a good idea because it's impossible with like a television or an Xbox. How would you know what the MAC address is? It's impossible to find out. So it's a cool idea. Really dig that. And then Aiden came by with some cool metamaterials, a material that compresses all the way in both directions when you squish it using these ovals. And he said it was designed by the Weiss Institute in Harvard. Very interesting material stuff that Aiden's checking out. I'm learning a lot about material science properties.
And one note, Stuff with Kirby said in Circuits.io you can upload Arduino code to the board too, which is kind of cool.
Yeah, no, very interesting. I didn't even know about it. I'm going to check this out because last I saw it was only for diagramming. I didn't know they had emulation.
Okay, all participants on the show and tell get an as seen on the show and tell sticker. Email support@adafruit.com and we'll send you outline. This is part of the Adafruit Live series. Woo, we do live videos all the time.
We're live.
Yeah, we're live right now. We're actually live on multiple networks. Just to give folks a heads up, we are on Facebook, YouTube, Twitch, and Periscope. Periscope now allows for people in the biz RMTP access, so we are piping what you're seeing onto Periscope, so lots of people who just have phones are able to watch the full Adafruit Ask an Engineer experience.
Yeah,
so,
I can see it.
Yeah, it's kind of neat.
Weird.
So we got that going on. In addition to all of that, don't forget to tune in to watch Tony D's desk. He just posted up a video. This is MicroPython beta for SAMD 21, Feather M0, and Arduino 0. It's beta. Play with it.
But that means it's the most fun.
Yeah.
Cutting edge.
Yeah. Okay. Back to the mailbag. Hi. Read a letter. These are the letters that we read every single week on our all-company meeting called State of Fruit, and we read them here for you. We really like it when you send these to us. This is George from Vancouver. Just wanted to write to thank you for your wonderful products. In particular, I just finished my first Arduino Pro Trinket and NeoPixel project, and it was a blast. Your documentation and articles are excellent, and as a result, my prototype worked exactly as expected the first time I tested it. A really enjoyable project, and the first of what I'm sure is going to be many Adafruit-fueled projects.
Yay!
Thanks to all the engineers and contributors who make Adafruit Trinket NeoPixel ecosystem so rich and well documented. Thanks again, George from Vancouver, BC. Thanks, George.
Thanks, George.
All right, time travel. It's where we look back in the world of makers, hackers, artists, engineers, and lately it's always been a surprise because there's just a ton of people that we put on Time Travel Tuesday that if you're not familiar with them, it's just a good weekly visit on your whatever blog reader thing you use, or just if you bookmark it. This is cool. You ready?
Yeah.
1921, Beatrice Helen Worsley, Mexican-Canadian computer scientist and academic, is born. This would have been her birthday. She was the first female computer scientist in Canada. She got a PhD from the University of Cambridge with Alan Turing and Douglas Hartree as advisors. The first PhD granted in what would be known as computer science. She wrote the first program to run on EDSAC and co-wrote the first compiler for Toronto's Franti Mark I, wrote numerous papers in computer science and taught computers and engineering at Queen's University at Toronto for over 20 years before her untimely death at 50. Okay, why have we never heard of her?
That's so
Have you
cool.
ever heard of her?
I've never heard of her. That's cool. She had Alan Turing as her advisor?
Yeah, so Beatrice Helen Worsley, I'm going to look up more about her, because what an interesting person to be the first computer scientist in Canada with a PhD.
And so she went to the UK to get her degree and then came back to teach. That's cool.
Yeah, and you know, when you go to like computer history museums, or if you just see things, you see a bunch of people, and you become familiar with them. And she's just someone, and I think we're pretty good at being aware of lots of the contributors and lots of the milestones and achievements. But anyways, so even when we look at our own Time Travel Tuesday, the team does a really good job of putting people in the spotlight. Okay, next up. Y'all are going to like this. Colin's Lab is back.
Oh, yeah.
And this is, I think, one of our best Colin's Lab videos, only because of how timely it is. If you watch the news, which you probably shouldn't, but if you do, sorry, it's like that right now. There's a lot of things about batteries. Particularly, there was a cell phone battery in the Samsungs, and a lot of people are like, oh, batteries can explode. What are batteries made of? What's battery? Because we're consumers, or a lot of us are, and these things are just sealed inside these orbs, these flat things. And eventually, you know, there's so much energy in such a small spot. It's also kind of like a bomb. So these things occasionally explode. So if you ever want to know the history of batteries, we have a video for you. It's Colin's Lab, and like I said, I think this is one of our best ones that explains so much.
He builds batteries, multiple.
So here we go.
Pile.
Buckle in.
When I say power, you probably think of a power outlet. But the fact is, batteries were used long before electrical grids or generators were in use. The term battery was first used in 1749 by Benjamin Franklin to describe a set of capacitors he'd wired in series in order to produce a higher voltage. He was using the word in the sense of a set of units connected together in series. But it eventually caught on so well that nowadays we use the term battery to describe even a single power cell. Of course, Franklin's capacitors are not batteries in the modern sense. We define a battery as a container consisting of one or more cells in which chemical energy is converted into electricity and used as a source of power. It would be another 11 years before someone used a chemical reaction to reliably produce electricity. In 1800, Alessandro Volta stacked copper and zinc discs on top of one another, separated by pieces of cloth soaked in salt water. He called this a voltaic pile, and it was the first source of relatively reliable continuous electricity in convenient pile form. And this is considered the first definitive battery. The zinc discs served as anodes, the copper as cathodes, and the salt water was an electrolyte. With these simple materials, we can easily create our own voltaic pile. Let's start by making a single voltaic cell in a beaker. The beaker cell produces 0.796 volts. Now I'll build a bunch of cells together as a voltaic pile, using these cardboard squares, which have already been soaked in the salt water. It's not sturdy by any means, but this leaning tower of Volta produces enough power to light a 5mm blue LED. And for the record, that is 9 cells in the pile, producing 6.33 volts. Not long after the voltaic pile was created, William Cruikshank came along and improved the design by laying it on its side in a slotted box. This helped prevent the electrolyte from leaking and causing shorts between plates, and it was known, appropriately enough, as a trough battery. But moving away from piles and troughs, in 1836, John Frederick Daniell pushed the battery further with his Daniell cell. The Daniell cell's defining feature was its use of a porous barrier between two different electrolyte solutions. In this example, we see the copper cathode sitting inside of a porous earthenware pot filled with copper sulfate. This pot is then submerged inside of a container filled with zinc sulfate and encircled by the zinc anode. The porous earthenware allows ions to pass between the electrolytes, but hydrogen bubbles are prevented from forming. This greatly increased the cell's lifespan when compared to a voltaic pile. The Daniell cell wasn't perfect, but its improved reliability made it suitable for widespread use. In fact, the standard for 1 volt is based on the output of 1 Daniell cell. All of the batteries we've talked about up until now would be considered primary, which means once their chemical reactions are depleted, that's it, they need to be replaced. Now, a secondary battery can be recharged multiple times and used again without being replaced, which is a good thing. In 1859, French physicist Gaston Plante created the first rechargeable battery using a lead anode and a lead dioxide cathode immersed in sulfuric acid. The chemical reactions inside Plante's lead acid cell could be reversed by passing a reverse current through it. A pretty amazing feature, but its weight and size made it impractical for most uses. Still, it was suitable for some things. In fact, lead acid cells are still used in cars today. So far, all of these early batteries have used liquid electrolytes, which pose pretty obvious challenges to portability. But in 1886, Carl Gassner created the first dry cell battery using an electrolyte paste composed of ammonium chloride and plaster of Paris. Because it didn't spill and could be used in any orientation, the zinc carbon cell opened the gates to many new portable uses, such as flashlights. The zinc carbon cell would eventually be refined by the National Carbon Company and evolve into our modern alkaline battery. You can easily see how little the design has changed over the years. Just a bit of help from a hacksaw. It's densely packed, but all the elements are still here. A carbon cathode down the center, a thin shell of zinc serving as the anode, and a thick, pasty black electrolyte. Of course, more and more nowadays, when we think batteries, we think lithium. In fact, you probably carry around a lithium battery every day in your pocket. Because of its low density and high electrical potential, lithium has long been considered an ideal material for use in batteries. But it wasn't till the 1970s that the first primary lithium cells were made widely available. Further developments from researchers around the globe led to the release of the lithium-ion battery in 1991, and later the lithium polymer battery in 1997. The major difference between lithium-ion and lithium polymer is in the electrolyte. The microporous electrolyte used in lithium polymer batteries means they can deliver the same power as lithium ions, but in a lighter, flexible package. Otherwise, the chemistries are the same. Inside of a lithium-ion cell, you'll find layers of anode, usually composed of carbon, cathode of metal oxide, and an electrolyte containing a lithium salt. So ultimately, batteries come down to chemistry. And although you'll hear about revolutionary changes being made to battery design, the basics remain the same: anode, cathode, and electrolyte. If anything major changes, I'll let you know.
And that was the latest Colin's Lab.
Okay.
So if y'all like videos like this, we can keep doing them. Just, pick up something once in a while. OpenDoc is the code, 10% off your Adafruit orders. It goes directly to support Colin and his endeavors.
It pretty much does go directly to Colin. I mean, we love
Portions
Colin.
of tonight's proceeds go to Colin. Okay.
And
next
everybody
up.
else you're going to see.
Yeah. All right. Next up, some open source hardware news. We were talking about being a supporting member of the Open Source Hardware Association. The summit just came up. And then, of course, this is Open Source Hardware Month.
Wow.
Yeah. So we're going to be doing a NYC Open Documentation Night at FatCap Fab Lab. And we're going to just be talking about why we do tutorials and videos and more. We'll see if we can broadcast from there. But that's one of the events we're doing, because a lot of people ask us, why do tutorials? You're giving away all this information. Why would you ever do that?
Why would you do that?
Yeah.
And how does that tie in with open source hardware and the way we view it?
Yeah. So, we'll talk about maybe some of the history of documentation and some of the things we've done. So if you're in the New York area, check it out
I'll be there.
upcoming on the Shapeway group. Okay. Speaking of
documentation.
Yeah, we're up to 1,084 tutorials.
Yes.
What do you got going on this week?
It took us 10 years to get to 1,000. We'll see how long it takes us to get to 2,000, huh? Okay, I had a couple things. I can't remember what we covered last week, so I'm just going to go through all of this stuff. So we've got the camera mount for the Hobby Creek arm. That's by Timothy Reese. It's a 3D printed project where you can, they're really, really nice arm, Hobby Creek arms that we have, you attach them to a pan of ice, and they're super handy. Well, he wanted to do more documentation, and so we wanted to attach the camera to make it easy for him to position the camera and take photos of him while he's soldering. So that project is a great one for that. We've got the tutorial for the Infinity Shred Data Dealer synthesizer, a Shruti synthesizer. That we sell in the store. We actually sold out of the kits pretty fast. We're going to get some more made because people like them. They're not limited edition, so we'll make them for a little bit and see how that goes. Cool synthesizer kit. This just shows you how to go through it, how to test it, uploading code and everything. The code comes pre-burned, but if you want to upload new code, I guess you could. Speaking of uploading code, we also have a tutorial from Scott. What's funny is Scott is actually working on our MicroPython port for the ATSM-D21. But it's what is it, the thing, the people who make stuff have to make tools to make tools to make tools. So as he's porting MicroPython to the SAMD, he kind of is creating this collection of tools and techniques that he's using. For example, he's had a couple hard fault issues, and he's like, well, I want to debug it with GDB, and that's my favorite debugger. And he didn't want to use Atmel Studio, which has a debugger built in. He's like, no, I want to use Linux. So he actually shows how to use the microtrace buffer that's built into the Cortex M0 Plus. It has this ability to, in hardware, give you a stack trace.
Yeah, it's like when mathematicians need to invent formulas to solve their math problems.
Yeah,
it's cool.
Yeah, or the person who designed the pick and place we had was actually a videographer. He was making video cameras, but he had to make a pick and place so he can design the video cameras.
Yeah.
So check that out if you're interested in the SAMD21. If you want to use GDB to debug tools, you can do it. Not too hard, actually.
Okay, what else?
To get it going. Got the Circuit Playground Sound-Activated Robot by Mike Barella. This is very interesting. It's a robot that uses Circuit Playground to run around, and it's got a Circuit Playground just controlling these two servos. But then it uses the microphone to do command control. So you use another Circuit Playground to make tones.
Yeah. And
those tones tell it which way to go, because there's no IR or radio on the Circuit Playground. So kind of neat. We also have that super simple Circuit Playground Jack-o'-lantern project from Phil B, a great beginner Circuit Playground project, a very safe way to add a candle flicker to your pumpkin. He also has 2 templates he released for carving your own pumpkin with a dragon or a tiger? A lion? I can't remember. 2 scary beasts.
Yeah.
I can't see. We got the tutorial for the Mad Science test tube rack with the UV LED. Sorry, it was a werewolf and a dragon. The test tube rack for UV LED reactive test tubes with cool light effects and a feather which is controlling the UV LEDs. Very creepy. Our beta release of MicroPython for SAMD, as we mentioned, that's new and cutting edge this week. And the F is for Felix hammer, sound effects hammer, and how to add sound effects to your props in general, and also how to add some patches and stuff for your costume with Ninja Flex. Okay. So a full costume build. You still have time to build it too.
Next up, we do this like, in New York City series on Twitter and Instagram. Here's a quick build.
That's how we make testers.
That's how we make a tester.
How a tester is born.
So we make our testers here. We do a functional test for pretty much all the things that we make here.
We make not pretty much, absolutely all.
Yeah.
Everything we make has
pretty much absolutely
all. Pretty much absolutely everything gets functionally tested.
Yeah.
And that's one of our tricks. The reason we can have such high quality products and such quick manufacturing is we do our testing in-house, and our testing is very fast and full coverage. We do first article inspection to reduce errors, and we don't rely on optical inspection because optical inspection is very time consuming.
Yeah.
Instead, it's actually faster for us to do a full functional test.
And speaking of engineers making their own tools, we use our own things that we make to make the testers too.
That's right.
So okay, so check out Instagram and Twitter during the week. Usually Mondays, Manufacturing Monday. Okay, as part of Electronic Halloween, we have a video from John Park. This is the spooky glowing liquid video. So here we go.
I'm John Park for Adafruit, and this is the Mad Science test tube rack. So this is actually a fairly simple build, but it has a great look to it, and you can use it as a Halloween prop or another spooky effect. The Mad Science test tube rack uses a feather microcontroller and ultraviolet LEDs. The LEDs are set into the stoppers on these test tubes, and they blink in a sort of spooky pattern. The test tubes are filled with water and ultraviolet reactive pigment. When the UV light shines on the pigment, a fluorescence effect is achieved, similar to how a blacklight poster works. I initially came up with the idea for this project by shining some UV light onto some tonic water. The quinine in the tonic water will fluoresce when you shine a UV light on it. Now, if you want to get lots of crazy colors, you need to go online and get yourself some UV reactive pigments. Here you can see I've got pink and blue, yellow, green, and so on. You'll take a very tiny pinch of the pigment and place it in a jar. Next, I'll add water, in this case about 50 milliliters, and give it a good shake. You don't want to oversaturate it. If you put too much pigment in, there'll be a lot of particulate matter and it'll block the UV light. So while this looks like a fairly dilute mixture, what you'll find is in the dark, when you shine a UV light on it, it'll glow beautifully. So I will try now to demonstrate with a UV LED, and we can see as the LED shines on the fluid, The pigment fluoresces. Let's try that with the lights off. Now that I know it's working, I'm going to go ahead and pour the fluid into a test tube using this spouted measure. And now I can take one of the rubber stoppers and place my LED into the hole in the stopper. The 5mm LED happens to fit perfectly. So I'll place the LED there and then plug the stopper into the test tube. And once again, when I turn on the LED, it glows. Once you've got your test tubes glowing, the next thing you want to do is put them in a rack of some kind. Now you can get some pretty nice wooden ones or plastic ones online or at a laboratory or chemistry supply. I decided to build this industrial spooky gothic one using 1/2-inch black iron pipe fittings and some laser cut acrylic stands for the tube holders, as well as this little support in the middle that holds the microcontroller. For the microcontroller, I chose a Feather Proto. This is the 32U4. You could also use the M0 chip, or any Arduino or other microcontroller, or even a Raspberry Pi if you like. In this case, I have 13 digital output pins that are supplying the roughly 3 volts per LED. Now, I got away without using current limiting resistors because the forward voltage of these UV LEDs is basically the same as the voltage of the Feather. But if you're using another microcontroller, you may want to make sure to use a current limiting resistor to avoid blowing up your LEDs, as cool as that might be. You can find all of the details for building this exact rack, and the microcontroller code is available online on the learning guide that accompanies this build. And that is the Mad Science test tube rack. I hope you have a spooky time building yours.
Okay, so 3D printing time. All right, so we got some time lapse. Noah and Pedro have been printing up a bunch of stuff, so every time they print up something, they do these time lapse. So we're just going to go through them really quick. Here's the D20 dual extruded with the new Ultimaker. Goes back. Nice little pumpkin. phone stand. But wait, there's one more.
That is some pretty sweet dual extrusion. I just
Yeah.
want to mention it. Like,
Yeah, it's cool.
That is
They're
nice.
having fun with it.
That is nice.
And last up, we have their video of the week. This is the Felix costume. Take it away.
Hey, what's up guys, and welcome back to another project video. I'm Noah for Adafruit. Halloween is right around the corner. Excuse me, I gotta go dress up real quick. If you guys haven't figured it out yet, I'm going as Fix-It Felix Jr. from the movie Wreck-It Ralph. So in this project, I want to show you guys how I 3D printed the golden hammer and added sound effects using an Adafruit audio effects soundboard. This is a really great way to add sound effects to your cosplay props, so be sure to check out this tutorial, follow along so you can add sound effects to your cosplay props. So let's check it out.
I can fix it!
I mounted a push button to the side of the handle so that when I press it,
I can fix it!
it'll trigger audio samples. But the cool thing is that the sound effects will change each time I press the button. The Adafruit audio effects soundboard is really easy to use because there's no programming required. You just connect it to your computer and drag and drop audio files just like a USB flash drive. I only needed a few parts to build this project, all of which can be found in the tutorial linked below. I made the hammer in Fusion 360 using components and shelled them out so that I can fit all the components and route the wires through the various pieces. I 3D printed the parts in gold PLA using the Sigma 3D printer from BCN 3D. I actually used a 0.6mm nozzle to reduce the print time, so I was able to turn a 3-hour print into just an hour and a half. I also set the layer height to 0.3mm since there isn't much detail, and that really helped speed up the print. So here's all the pieces, a total of 6. I didn't do any post-processing or painting because the parts are already gold. So after the 3D printing was done, I started working on the electronics. On the back of the audio effects board are these 2 pads, which can be used for powering the circuit. So I cut up 2 pieces of wire and connected them to the ground and positive pads on the audio effects soundboard. A switched JST breakout will allow me to connect a LiPo battery directly to the circuit. I connected ground to ground and the positive to the SW pin. Then I can plug in the LiPo battery and test the connections. The little switch here will allow me to turn the circuit on and off. Next, I soldered up some more wires and connected those to the audio amplifier. 4 of these connections will go from the amplifier to the Adafruit audio effects soundboard. Be sure to check out our guide on the Adafruit learning system for a full circuit diagram and step-by-step instructions. So after that, I can work on the push button and connect some wires to the leads. This one has a built-in LED, so I need a second pair of wires and a resistor. There were some wires already on the speaker, but they are too short, so I removed those and added some longer ones. Next, I installed the speaker into the cover of the hammer by pressing it down. It just snaps into place with the front side going in first. Then I threaded the wiring from the speaker through the head of the hammer. Made sure to pull the wiring all the way through and press the cover into the head to join them together. The base of the hammer has these 2 holes, so I inserted the wiring through the big one and out through the smaller one. Then I fitted the neck of the hammer into the bigger hole. Next, I'll need to thread the wire through the rod and pull the wire all the way through.
The tip of the rod actually has threading, so I can twist that into the base of the hammer until it's fully tight. Okay, now onto the handle. Wire goes in through the top opening and out the other end. Again, pulling wires all the way through. Then we can insert the rod into the handle and press them together. After all that, I connected the wires from the speaker into the audio output of the amplifier, making sure to connect positive to positive and ground to ground. Next, I fitted the wires from the push button into the hole on the side of the handle. Then, I mounted the button by pressing it down until it's fully flush with the handle. This push button has a built-in LED, so I wired that into the JST breakout board. Then I wired the push button to the Adafruit audio effects soundboard using pin number 0 and ground. But this could be any pin number, just make sure the audio file names match. Okay, now I can plug in the battery and test the circuit to see if everything works. If it does, the LED will light up, and when I press the button, it'll trigger the audio samples. Remember, the little switch on the JST breakout will turn the whole circuit on and off. So once it's tested and all good, we can then start installing the components into the handle. So I carefully fitted the components inside and used some mounting tack to hold them in place. The little cap piece fits on the bottom and closes everything up. And that's it, there you have it. Now I have some sweet sound effects to go with my 3D printed prop. I also 3D printed the patches and buttons for the t-shirt. The patch on the hat came out really nice because I swapped out the color mid-print to get these two colors. And the patches were printed in Ninja Flex filament. The costume for this cosplay was really easy to put together and pretty fun.
So there you guys have it. That's how I 3D printed and added sound effects to my 3D printed golden hammer. So if you guys are looking for a way to add sound effects to your cosplay props, be sure to check out the tutorial. I want to hear what you guys think. If you guys have any ideas, go ahead and leave them in the comments below. That's going to be it. Have a safe and happy Halloween. If you excuse me, I gotta go fix a 3D printer.
Oh, Noah and Pedro, if you could only fix all my problems with your magic hammer. Okay, so Thursday is Hangouts with Noah and Pedro. Watch it tomorrow. Late data. It's almost time for new products. But
Is it that? Wait,
it's almost time. But
no, wait,
before that, yeah, I know you're waiting. I know you're waiting. Open Docs code.
Okay.
All right.
Now's the
You hear?
time.
Yeah, do your thing.
Yay! It's new, 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 new,
Yeah.
new, new, new,
Yep.
new, new, new,
It's always new.
new, new, new.
It's super new. Okay.
Is that a tune new?
Let's do this.
Okay.
We'll speed through these.
Back
this
to
week.
new.
Okay.
Yeah.
We got a pack.
Yeah. Okay. This is Bubble Sort Magazine, a real Twitter pack. This is a pack that goes with the new Bubble Sort magazine. There's a project in it. The project is you use an Arduino and a piezo and some components, and you learn to breadboard and you learn to make a real tweeter. Like you
A
can
literal tweeting bot.
It literally tweets to tweet. And can you go to the next page? So I think
Yeah.
this is the
Well, this is
magazine.
the zine, yeah.
This is the zine, so you can subscribe to it. Literal Twitter bot is the project, but it's just a really cool magazine zine. I think it had a crowdfunding campaign, but you can probably still pick them up and check out the very cool and well illustrated electronics and computer knowledge that you can learn. And we're glad to
right.
have a pack for their magazine. So pick it up if you want to build this project.
Okay, next up, antenna.
We have an antenna. This is a UFL antenna. It goes with, pretty much all of our cellular modules, the Fona 800, the Fona 808, even the Fona 3G. We have had short antennas, but there are some situations where you want to have the antenna nice and far away from your project. So in addition to the 75 millimeter antenna, we now, for the same price, basically, have a 300 millimeter antenna. It's perfect for quad cellular projects. It's
Yeah.
a nice little antenna.
Okay, next up. What's this thing?
This is the touch board from Bear Conductive. Bear Conductive is known for their really great conductive ink. It's company's called Bear Conductive, but you don't actually put it on your skin. It's just conductive ink, and
It's not just for bears.
it's not for bears.
Okay.
Yeah, it's not for bear or for bear people,
All right.
either way. but it's just conductive on its own. It's not silver-based. It's like a plastic carbon-based material. And this is their touch board. What's really interesting about it is the way they designed it. It's meant for a Pi Zero because it's a low-cost Linux computer. You upload their image to it, and then you can turn your Raspberry Pi Zero into an audio effects board or any kind of effects board using capacitive touch. And you've got those 12 big pads on the top that are labeled E0 through E12. Those are the capacitive touch pads. Yeah, I'm hitting them. And then when you put those flat against a piece of paper, or you can clip onto them with alligator clips, you can create these beautiful fruit drums or
Aren't you
whatnot.
glad we have
I am so
a photo?
glad. And then
Okay.
can we just show it really fast? Because it's a little interesting how they did it. So most Pi hats, you have the Pi and then you plug the head on top, but this is actually one that you put it upside down. That's how it's supposed to work. And so the Pi hat is actually flat against the table. And so now if you wanted to add conductive ink against like a piece of paper or cardboard, it would lay flat because it's a totally flat surface. So it's a slightly different way of mounting it, but I think it's kind of cute and smart. And looks like they added an audio output as well with a headphone jack. So you can connect it to a stereo or connect headphones to it. And they just use, there's the NPR 121. Yep, the NPR 121 capacitive touch sensor. And then an audio circuit that basically does the PWM audio that doesn't exist on the Pi Zero, but you can add it and it just looks like a headphone out. And there's also an RGB LED on here you can control with their library.
Nice looking board too.
Very nice.
Okay.
Gold, black, white.
Speaking of bears, I knew there was bears. Bears.
There's
There's
more.
actually red bears. Yeah.
There's red bears.
So we
There's
have
bear conductives.
Yeah, I wasn't messing around.
No, you're right.
Okay, so this is the Red Bear IoT Fat.
Yeah, so this is a mini hat-like thing. It's not literally a hat because hats have to be a certain size.
Fat.
But it's a fat, which is like a Pomeranian hat, or as I like to say, Pico hat.
Yeah.
It's about half the size, and it's the size of a Pi Zero. And what this board does, which I think is really neat, is it adds, I think it's an SDIO Wi-Fi and cellular module. I think it's probably similar to the Broadcom chipset that is in the Pi 3, but this is basically an add-on, and you can just plug it on top of a Pi Zero. Now, of course, you could always add USB and Bluetooth with the USB adapter, but what's nice about this module on this board is you don't need to have to take up the USB port. It plugs in, and I think on the back they have it uses the SDIO interface, which is really neat because it's exposed with the Pi 2x20 connector. And basically you get Bluetooth and Wi-Fi at a fairly low cost and very compact form factor for your Pi Zero. So very handy. Kind of turns your Pi Zero into a Pi 3 in a sense.
Okay.
Very nice. So check that out. A good accessory for your Pi Zero.
Moving right along.
Not enough.
An automation hat.
And not enough hats or fats. This is the automation hat from Pomeranian. So we have a hat or cap from everybody today.
Yeah.
This is a
Half-assed.
multiplexitor, lots.
Tons.
So this is the automation hat. So this is kind of a jack of all trades for automation and motor control or relay control. So you've got 3 24 volt, 2 amp max per relay. So these are, they're actually the same relays that we use on the Relay Featherwing. So little mini surface mount relays, and there's a relay driver. There's an analog digital converter chip on there. It actually is a hat because it has the hat identification EEPROM. Trying to see what else is on here. I think that's it. It's fully assembled. Can we go to the overhead because I'll show it off. Yeah, just taking a quick look at it. So you got the 3 relays. You've got a power communication and a Warren LED. You got the EEPROM for the FAT, analog digital converter up here, some syncing outputs. So you have basically a Darlington, I think a ULN 8003 or something. Yeah, UN 2003. So an 8-port buffered output, so you can control these relays from that. And then here's the relay outputs you get. Normally open, common, normally closed. So kind of like you can control a whole bunch of stuff. Here you can get the GPIO for RX and TX So good for any kind of motor control or robotics control or home automation. Very handy
Okay.
little hat.
And moving right along, these are
Works
the
with
boards.
all
that-
Raspberry Pis. So these are all Raspberry Pi products. They
Yeah.
actually work with any Raspberry Pi, even though some are Pi Zero shaped or size. They all work with all
Okay, that was a question.
2 by
already
20 Pis.
answered.
Yeah, it's a little. Sometimes people like them small, some people like them big.
All right. And then we have 2 RTCs, and we'll try to do some questions. So
Okay.
here you go. What you got?
Okay, so we finally are back into Adafruit making some stuff, and so today we have a twofer. We have 2 real-time clocks. They're very similar, so I'll explain the differences between them.
Yeah. Here's
We
the first
have
one.
we have the PCF 8523 real-time clock breakout board, and this is a real-time clock. So if you add a coin cell battery to this, it will keep time for like 5 to 7 years. Even if your microcontroller loses power or your Raspberry Pi loses power, whatever, it will keep ticking. It'll just keep track of time for you. This real-time clock is made by NXP. It's a very good real-time clock. It works with 3 volts or 5 volt logic. It's lovely.
Yeah, that matters.
It works, we have code. We actually tested it with a Raspberry Pi. It works
Yeah.
great. We have code for Arduino. Works great. It's not exactly the same code as a DS1307, which is a very common real-time clock, but it can be easily adapted.
Okay.
So if you have code for the DS1307, you can, with just changing a couple register locations, you can make it work with the PCF.
Then there's this one who looks
8523.
just like it.
This one looks just like it, but it says DS1307. So the DS1307 is from Maxim, and it's also a real-time clock. It's an older real-time clock. It's been around for a very long time. You see in the top, sorry, right here.
Yeah.
This is RTC, and then a different part number.
It's like,
And the deal with the DS1307, it's a little older. It's kind of more supported by things because it's an older, more established real-time clock. It's very popular. However, it is 5 volt power only. So it's okay for use. You can use it with 5 volt power and 3 volt logic, but it's kind of, if you have only 3 volt power available, like for example, our Feather line, when we made a real-time clock for it, we used the PCF 8523, not this chip, because this chip doesn't like to be powered from 3 volts. Another thing, a side mention, the DS1307 does not like to be run without a coin cell.
okay.
You need to run it with a coin cell. The PCF can run without.
Yeah.
I don't see why you would, but just
All right.
as a side note. Also, the DS1307 is more expensive. So it's quite significantly more expensive, almost twice as much, because Maxim charges more money than NXP. So these chips, are a couple bucks more. So we have both. If you need to maintain compatibility with existing code base that's using the 1307, use this one, because that'll give you, it's drop-in replaceable, it works great. If you are flexible with the code, you're willing to use the Arduino library, or you're using a Linux computer where you can, like a Raspberry Pi, where you can change the text from DS1307 to PCF 8523, it'll work perfectly fine, and we suggest the PCF.
Okay.
But we have both.
And multiple choices for measuring an imaginary thing that doesn't really exist.
Exactly.
Okay.
I prefer the PCF, and I'm moving, the data logger shield is moved to the PCF because it can work with 3 volt or 5 volt just fine, and it's also a little less expensive. But we're going to keep around somewhat deprecated but still quite popular DS1307 series.
Okay.
And if you need a precision real-time clock, we always have the DS 3221, 2331. I don't remember the exact part number, but check the product
all your-
listing. It's a precision,
all your time needs.
super precision real-time clock, but of course it will be even more expensive because it's temperature compensated.
Okay.
So nice, more common, higher quality.
Okay.
Many options for your real-time clock needs.
All right.
That's new products.
And with that is new products. Good work, Lady Ada.
Woot.
You did it.
Yeah.
Okay, we're going to zip through some questions. First up here is Doc, that's code. Anything you saw that's in stock, 10% off. Do it before 11:59 p.m. Lady Ada, it's question time.
I'm ready.
Yeah. Okay. Questions. The first one had a clock question. If you can only choose one of the clocks that Adafruit makes, RTCs, which one would you choose?
It's not like there's one that's the best.
You only have one. You're on a desert island. You just have one.
I would pick the DS3231 because it's the most precise, and if price is not an issue, if price is something you're sensitive to, then the PCF 8523 is a very good choice.
Okay. Next up, will we carry the Red Bear IoT FAT without the headers pre-soldered for those of us who need to use it with stacking or short headers?
This was the only option they gave us, but I can go back and see. I was surprised, actually. I thought it would come without headers, but it seems like maybe they only told us about this one option.
Any input on the codebender.cc closing news? Yeah, if you check out our Adafruit daily newsletter, or if you, did I put it on the blog? But we have a daily newsletter where we don't spam people. Codebender shutting down. There is a post on their website called Next Chapter. They just couldn't figure out a business model that made sense for what they wanted to do. So look at the post from the CEO of Felix, and then I think there was some participation on Hacker News, and they kind of say all the things that they needed to do and spend.
They actually were very transparent.
Yeah, so I think it was something like $25,000 a month to run that site. So we had played around with Circuit Playground running on it. We wanted to see what happened. We don't really use Codebender. That was the first time that we had requested a board that was in there. So we wanted to see, like, okay, what's this cloud-based IDE-like thing? We think that's where the future's going. But to find a business model for a software as a service only play, it's a little challenging. That's why we like to do hardware.
Embed just has ARM backing it.
Yeah.
You know, there's a ton of money there, and they basically get ARM and all the ARM licensees to chip in. But it's tougher if you don't have hardware to license. You know, software without hardware is a challenge.
Recommendations for water-resistant switches?
You know, our rugged switches they're not waterproof. They're somewhat resistant, but you can look on go DigiKey or something and search for waterproof switches. You know, water resistant, waterproof. These are all things that you'll have to look at what IP factor you need.
Okay. Do you know is it easy to know the differences between the different ESP32 modules? There's ESP32S, Vroom, and then what module are we gonna do?
The 3212 is the one from Aixing. I don't remember how to pronounce their name. Aixing. And then Vroom is the one from Espressif. But right now, none of them really exist so much. So we don't have any thoughts on them. They're all very much in developer mode.
Okay, someone wants to know how can they get involved in the MicroPython at SMD21 port. And as Tony said, pull request issues, good to do on GitHub. That's where we're doing it.
GitHub is the place to go.
Yeah, please help out. Is there a way to refine the Feather Bluefruit code to speed up getting data specifically from the control pad to Bluetooth F? I only need the Feather to check for buttons on the control pad, so I want to ignore everything else. Is this possible? Well, we put the code out there, so you might be able to just...
it's not going to be that much faster.
You could mess around with removing stuff, but I don't know if it would change
you can
too much.
can tweak stuff, but it's not going to be... I mean, maybe there's a timeout, I don't remember, for reading bytes, but you can check out the sketch. It's very simple. It just reads data from... The control pad actually just sends, you know, a exclamation point B and then the number.
Yeah.
So you just have to look for that.
How does Adafruit IO compare to other cloud services by like Blink.com? Well, ours does data logging, and it's we're in free beta. I think Blink charges for credits, but you know what's the cool thing? You can try both. Figure out which one works for you. Yeah.
It's cool.
Okay. Which one offers data faster wirelessly? The Feather M0 Wi-Fi or the Atwing 1500 or Feather Bluefruit M0?
Wi-Fi is always going to be faster than Bluetooth. Bluetooth is low energy and Wi-Fi is high energy, so you're going to get all other things being equal. You're going to get more data transfer from Wi-Fi.
When was Adafruit founded? 10 years ago?
Yes.
And all right, I think we got all of these. We speed rounded because we're right at 9 o'clock on the dot. Okay, well, thank you, everyone. And if there's any more questions, we're here next week, of course.
Yay.
Lady Ada, let's give away something.
Let's give away something.
What do you want to give away?
I'm going to give away a PCF 8523 real-time clock. It's pretty sweet.
You can measure time with it. What are the rules for the trivia question?
The rules are if you've won something before, you can't win again. Only one winner per my lifetime. The first person to answer the question in one of the chats, as Mr. Lady Ada deems correct, wins the fabulous prize, which is a PCF 8523 real-time clock. Works with Arduino or Raspberry Pi. How great is that?
Okay. All right, the question is, in 1954, which company announced the first transistor radio? Be a little bit of a surprise. 1954, company that some of us know, announced the first transistor radio. Which one is it? So he's got lots of.
The first transistor radio.
Yeah, I'm looking for the name of the company, and I got this, and yeah, everyone says Amelia Earhart. Nope. Congratulations, Paddle and Pink, Texas Instruments. That was one of the companies that I was looking for. Paddle and Pink in the YouTube chat. Congrats. In 1954, two companies working together, Texas Instruments of Dallas and Texas and Industrial Development Engineering Associates, IDEA, of Indianapolis, were behind the unveiling of the Regency TR-1, the world's first commercially produced transistor radio.
That's cool.
TI hanging around. They're not going anywhere.
Texas.
Yeah, that's what they did. So anyways, if you want to read about that, it's on our time travel
Neat.
section of our site.
I didn't know TI. I mean, I knew they had a part in it, but I didn't know they
of
designed
course.
it.
Of course they
That's
do.
cool.
Okay.
I learned so
So,
much from the show.
Yeah.
That you
so
put on for me.
Paddle and Pink, email support@adafruit.com and tell them that you won the prize, and it's PID 3295. That'll help them. and our team.
3295.
3295.
Thank you.
And we'll send you out one.
Sweet.
Good work, Paddle and Pink. Okay, that's the show for tonight, folks. Don't forget, codes open up. If you like all this stuff, because I don't think anyone's doing anything like this. This helps us. This helps us go.
We will do this.
Yeah. So we'll see everybody next week. Thank you to all the Adafruit team members here and remotely and beyond, and people we don't even know yet. There's more people we don't know than we do know. Isn't that weird? Yeah.
That's very true.
And we'll
Billions.
be here. Yeah, we'll be here next week. Thank you, everyone. And to play us out tonight, Microsoft visited and interviewed you about open source, and they filmed a video about open source. Definitely a different Microsoft. So they had a camera crew and everything, and we're going to play it right now. So it's Microsoft talking to you. There's some Adafruit scenes. This was filmed a while ago. It just got released. And you could see some of this floor in this video when we were just putting our manufacturing floor here. So we'll play it out.
That was a while ago.
It was a while ago. Here's a picture of Cat.
Meow.
Yep. Your moment of Zener. And
Later, folks.
hey, folks, here's a vid.
My mission, which is also the mission of Adafruit, is to show everybody in the world how much fun and creative it is to be an engineer. We make open source hardware and educational electronic kits. Microsoft decided to partner with Raspberry Pi, the delicious single board computer, and it has everything you would normally expect a big computer to have, but it's designed to be very small, very low cost. Microsoft and the Raspberry Pi Foundation said, we want to have a starter kit for the Raspberry Pi because you want to have sensors and wires and cable and the accessories, all the things you need to actually build a project come in one box. And that's what we're really good at. Millions of people are now able to do Windows 10 IoT development and use that to not just move pixels on a screen, but make LEDs blink, sense things, make a motor move, make a robot drive around. It's powerful, perfect for prototyping and developing Internet of Things. A maker is anybody who is already doing what they love creatively and they're just adding technology into it. We do a weekly show and tell. We actually get to see who makers are. They show up and they show off their project. And we'll get everything from a Girl Scout troop making their first robot and showing it off to people who work in industry and they're web designers and they're making a light that goes off when their GitHub request gets accepted, to grandmothers who are making knit coats and they're embedding LEDs into them. It's important to celebrate and highlight the kind of people, the kind of makers that we think are good for the world, and we're gonna get more of those. I'd like to do a lot more with Microsoft. We've got millions of Microsoft developers. Let's get them doing open source software, open source hardware, be part of this maker community.